Hello students, welcome to class 8 maths. Today we will discuss chapter 3 which is about concepts of polygon. First we will discuss what is a polygon. A polygon is a simple closed curve made up of only line segments. These figures are polygons, this and this. So these are the curves that are polygons. These figures are not polygons. These are the curves that are not polygon, okay? Now we will discuss what is plane curve. Plane curve is when we join a number of points without lifting the pencil from the paper, we get a plane curve. Such that these are plane curves. These are made up of without lifting the pencil. But these are made up of on lifting the pencil. So these are not curves and these are curves but they are not polygons. Okay. Now we will discuss diagonals. Diagonal is a line segment connecting two non-consecutive vertices of a polygon. Okay, these are diagonals. Now this is interior of diagonal and this is exterior of diagonal. Now we will discuss what is convex polygon. Convex polygon have no portions of their diagonals in their exterior. All are inside. This is the polygons. All diagonals are inside the polygon. Okay, this is the diagonal and this is the diagonal. It is inside the polygon. Given here are some figures. These all are. You have to say which figure is simple curve. The answer is 1, 2, 5, 6 and 7 are simple curve. These figures are made up of without lifting the pencil. And the definition of simple curve is a simple curve is a curve that doesn't intersect itself, while a simple closed curve is a simple curve that also forms a loop connecting back to its starting point without crossing itself. These are here is the starting point and it is coming back to a starting point. So these are simple curve. 1, 2, 5, 6 and 7 are simple closed curve. 1, 2, 5, 6, 7 are simple closed curve. Simple closed curve must have no endpoints and enclose an area. Okay. Next, 1 and 2 are polygon. Here in figure, these are polygons. Figure 2 is a example of convex polygon. Figure 1 is concave polygon. Figure 1 is concave polygon. Okay. What is concave polygon? You should know concave polygon have portion of their diagonals in the exterior. Example, you see this figure PQRS. In this figure, diagonal QS is outside the polygon. Okay, so it is an example of concave polygon. Okay, now question number 2 is how many diagonals does each of the following have? First, a convex quadrilateral, it has 2 diagonals, this and this. A regular hexagon, it has 9 diagonals. A triangle, it has 0 diagonal. This hexagonal has 9 diagonals. Question number 3 is what is the sum of the measures of the angles of a convex quadrilateral? Will this property hold if the quadrilateral is not convex? This is the answer. ABCD quadrilateral is formed by 2 triangles. This triangle and this triangle, triangle ADC and triangle ABC. As the sum of the interior angles of a triangle is 180 degree, sum of the measures of the angles is 180 degree plus 180 degree, that is 360 degree. This quadrilateral ABCD is not convex. On joining BC, it is divided into 2 triangles, triangle ABC and triangle BCD. In triangle ABC, angle A1 plus 2 plus 3 is equal to 180 degree by angle sum property of triangles. In triangle BCD, this triangle 4, 5 plus 6 is equal to 180 degree by angle sum property of triangles. So on adding all these triangles, angles 1, 2, 3 plus 4 plus 5 plus 6, we get 360 degree. So angle A plus B plus C plus D is equal to 360 degree. This property holds if the quadrilateral is not convex. Okay. Now we will come to the point regular polygon. A regular polygon is both equiangular and equilateral. Example, square and rectangle. A square has sides of equal lengths and angles of equal measures. Hence it is a regular polygon. Angle sum property. What is angle sum property? The sum of the measure of the three angles of a triangle is 180 degree. This is called angle sum property. Next question is, what can you say about the angle sum of a convex polygon with number of sides 7, 8, 10 and n? The sum of all the angles of a polygon of side n is determined by the formula n minus 2 into 180 degree. Number of sides is 7. So n is equal to 7. N minus 2, 7 minus 2 into 180 degree, that will be 900 degree. Sum of the measures of the exterior angles of a polygon. The sum of the measures of the external angles of a polygon is 360 degree. In this question, find measure x. This is exterior angle, is this figure. Here x plus 90 degree plus 50 degree plus 110 degree is equal to 360 degree. So we will find out x. X is equal to 110 degree. Question number 2. Find the number of sides of a regular polygon whose each exterior angle has a measure of 45 degree. Solution is total measure of all exterior angle is equal to 360 degree. Measure of each exterior angle is equal to 45 degree. Therefore, the number of exterior angles is equal to 360 degree by 45, which is 8. The polygon has 8 sides. Okay, thank you.